Wow, putting on my glasses is a lot of work. Can't believe I shut down all the technology. I guess that's the theme of our day. Let me make sure people are seeing this. Let me see. Okay. Whew. Looks like we're back. Thank goodness gracious. You know, sometimes I go to put my goggles on and I just get a little verklempt, a little overwhelmed. So I'm glad that you could join me again here. Where were we? We're on part 4 of our simple machines. And, thanks for bearing with us with our technology as we're moving and grooving through this. Thank you so much. So we just talked about screws as a combination of an inclined plane and a wedge. They do this as a way of transferring energy. This is part 2 of part 2. Transferring energy down the inclined plane that goes in a spiral. It's also a wedge. So now, the one that's going to be the most important for our workshop today and our workshop next Wednesday, that's the 5th, the lever. And the lever is super exciting. The lever is kind of like a seesaw, if you've ever been to a playground. And it transfers energy by creating a fulcrum. And the fulcrum is the center of that lever, or the turning point of that lever. Okay, so, and there's class A and class B levers, but we're gonna keep it simple for today. And notice that as soon as I put a lever onto a fulcrum, the transfer of energy moves with gravity, right? So I can use gravity as a way of putting force going upwards. Ooh, let's see how we can do this. Whoops. So I can put energy as part of gravity and still have the force go upwards, right? So like I said, all simple machines are a way of transferring energy more effectively. And so it's a lot easier to have gravity on my side to move this down as a way of getting this up than it would be if I were really small and underneath this and pushing it up. Does that make sense? Okay, I'll take your word for it. And then number 6 simple machine is a pulley. And we skipped number 5. Number 5 is a wheel and axle. And a wheel and axle, these ones are pretty common. You'll see them in all kinds of different mechanisms, also in cars. The way that the 2 wheels of a car move together is a wheel and axle. And the way that this uses and transfers energy more effectively and efficiently is, see, I can move this axle really a pretty small amount, right? I'm just moving my fingers like a ½ an inch. But the way that my wheel is moving is way more than a ½ an inch. So I'm using a lot less energy moving this and asking that energy to transfer to here than I would if I were to just move this. And so this is a way of transferring that energy and moving that weight more effectively. These are often also found in clocks. If you're making any sort of automata, you've probably used a wheel and axle at some point. You can get more complicated with cams. But I have a feeling that as you start to learn more about these, you'll see them more and more everywhere, but especially in puppetry. And then the final one that I want to talk about today is a pulley. And I gave you a sneak peek of the picture. This is a pulley. My images are not so great, but what happens here is that a wheel turns. And as the wheel turns, it transfers this string or chain or cord and makes it so that it moves along this track. Oh, Kathy Campen, I'm glad that you were able to join us back here again too. Sorry that happened. But I want to think about all of these simple machines in the context of our homes. And I'm gonna ask you to spend the next 3 minutes going on a simple machine scavenger hunt. I think you'll start to see a lot of them. I'm going to show you, while you're doing that, I'm going to show you one of my simple machines that I found in my house. And I mean, I'm making puppets, so maybe it's not quite, maybe I have more simple machines available than others, but this I was building a toy theater stage and I wanted there to be a curtain that opened and closed. And so using a pulley, I was able to make it a lot more special and a lot more effective. And I'll lift this up so you can see the wheels. As you can see, there's a wheel here, and there's a wheel on the other side over there. And I move this cord to which this fabric is attached. And so the wheel is doing a lot of the work for me of that transfer of energy. So just to review our 6 simple machines. We've got levers, pulleys, inclined planes, wedges, screws, and wheel and axle. That's right. Glad you could join us. Exactly. So those are our 6 simple machines, and they're everywhere. Even like a light switch is a kind of lever. Like I said, your car has wheels and axles. Maybe you have a little curtain system for a pulley. I think I could have more hanging plants if I had more pulleys. Not that I need any more plants. And all of these are effectively and efficiently transferring energy. So I would love to think and hear about all of the simple machines that are in your house. So if you see any, please let me know. I would love to hear about them. I also want to talk a little bit about clothespins. The humble clothespin is really special because it has it's 2 levers at work, right? Here's our fulcrum, like we talked about, the turning point of the lever. And it uses 2 levers in conjunction in order to attach, right? If I'm moving this, that's a lot more difficult than moving this. And the resistance of the spring lets us circumnavigate the force that we're using in order to make this effective, okay? Now, if you've been on our pages and watching our stuff, today I asked you to join us with a spoon and a cup. Whether you have those things or not, you can take a second to go grab them. I'll go slow so we don't miss anything. But if you've got a spoon, I just want you to kind of hold it to see how the weight is distributed. And I know it sounds silly. I know you've probably held a spoon before, but it lets you know a lot about where and how weight is transferred and how effective these levers can be. And levers are going to be our big focus. So if I hold it here, it feels a lot heavier, or it's a lot more difficult to move this up and down than if I hold it here, right? That's a lot easier. And what about if I hold it here? If I hold it here? And I want you to really physically feel this, so go ahead and use your spoons to try this. See if you can find a balancing point for your spoon. All right, kind of found one. I'm also really good at this. It's like a secret talent. Yeah, there are so many different things you can do with spoons. So, if you've got a spoon and a cup, I'm wondering if you also might have a grape. And I like to eat my grapes kind of frozen, so they're a little cold. But, using the things that you have in front of you, I'm wondering if we can find a way to use a lever to get a grape into this cup. Rube Goldberg made all different sorts of machines to perform mundane tasks using really complicated mechanisms. That's a little above and beyond what we're going to do today, but maybe in the future we could work on Rube Goldberg machines. So what you'll need is a fulcrum, right? And I'm kind of using this, my old wheel and axle as a fulcrum. And if I push down on that, I'm kind of using a lever to create a catapult. And like I said, a lever is just a way of transferring energy. All simple machines are. But maybe if I do this, then that's a way of, okay, ready? Oh, where's my cup? Oh dear, oh no. Oh goodness. Thanks for being with us anyway, everybody. Okay, let's see now. Where were we? we were trying to use, I know that was pretty silly, right? We got a lot of silly moments today. I'm glad we can just be patient and roll with it, you know? But if I press down on, let's get some of this out of the way. If I press down on here, then that's illustrating that weight transfer that we had talked about earlier. And if you've made puppets, maybe puppets that go like this, you know that putting your hands directly on the kind of action that you want makes it a little bit difficult, right? Like this is kind of a lot of effort. And if you were to do something that was just like this, that might be a lot. If you could create a mechanism that makes that effort simpler, then you're going to be thankful in the long run. So if I create a lever to do the job of putting the grape in the cup for me, I don't know if this is going to work. Let's see. Ooh. No, not quite. I think I need a bigger level, a bigger, higher, more effective fulcrum. Maybe this. I've got kind of a glue bottle that might be slightly more effective. Okay. Maybe yeah, that feels a little more like it might have a little more force. Okay. And maybe I'm not going to get it in the cup today. Ready? Oh, so close. So close. Do you think we can make it? But this is just a way that a lever is going to be really useful in a way of transferring energy. Because like I said, it's going to be a lot easier to use gravity on my side with a lever pushing down in order to transfer this side up than it is if I were to just sort of to try to make this go up. Whether we get the cup in the grape or not. The grape in the cup or not. Okay. Let's try again. And I hope you're trying along at home. I hope that you're flinging grapes across your room, as long as you clean them up at the end. 1, 2, 3. Oh, so close. And I'm just using my finger as a fulcrum, but if you're watching at home, maybe you're using tape or something more effective. Yeah. 2, 3. Gosh, I feel like Ben Simmons in the first half of the season, you know? Whew. Okay, 1, 2, 3. 1, 2. That one went all the way across the room. But you understand the way that these different simple machines can help us move energy and weight more effectively and more efficiently. Oh my goodness, I almost forgot about one of the best examples of a pulley that I know in puppetry is a cranky. A cranky is kind of just like a pulley. So I want to move on from this in order to set us up for what will be our next STEAM in Puppetry workshop. I'm really excited because this is going to be the one on next Wednesday, May 5th, May 6th, where we actually make a puppet, right? And we're going to have all different sorts of recycled materials, but we're going to make a puppet that has a mechanism next week based on the lever that we learned today, the different uses of a lever. And so one thing that I think is important about puppetry is that puppets often communicate really well through gesture, right? And that means maybe a wave, that's a gesture, thumbs up, that's a gesture, different movements that we make with our body that express something to someone else, that's a gesture. And I want to make a puppet that can wave next week. And maybe the wave goes up and down, maybe the wave goes side to side, but there are different ways that we can think through the way that a wave communicates. So I'm going to go grab the 3D sketch prototype puppet that I made in the last STEAM in Puppetry workshop. Give me 1 minute. Okay. So last time we were here, we did this. And we kind of made different puppets out of the recycled materials based on the sketches that we made, right? So we were working from 2 dimensions to 3 dimensions, and we were working on design and scale. Another thing that I think is worth thinking about in this capacity, and as you're using spoons and grapes and different things, is the concept of like hacking, because I think that it's really interesting to use objects outside of their intended purposes. And puppetry does this all the time because there's no puppet supply store that you've ever been to, or, well, maybe now there are, but using different materials outside their initially intended or marketed purposes is a way of hacking that I think is abundant in puppetry and something we can do. So now I'm maybe gonna think through those gestures and think through what is available in a wave, right? And maybe you see a wave and maybe you pass a wave. So just think of all the different ways you can wave at someone, right? I think maybe you could wave like a little shy. You could wave really, like you're really excited to see someone. You could wave like a sneaky wave, like a. You could wave like you're not sure if the person is waving to you. You could wave. Maybe you guys can think of some. Do you have any ideas about how to wave? I'm just trying to get the point across that a gesture is something that a puppet does really well, and what we're going to design on May 6th is a puppet that uses a lever to wave. Right? Now that we've introduced our 6 simple machines, now that we've introduced making 3-dimensional puppets out of a 2-dimensional idea, the third one is when we're really gonna make it happen. So, different ways of waving, different simple machines, all different things that we're learning today. So yeah, I think that thank you so much for everyone for hanging on with all of our technical difficulties today. We started late, we got cut off in the middle, and still you're here. So thank you so much for doing that. I really appreciate it. Thank you people who support the Ballard Institute. We are happy to make all of our programming free and accessible, but if you have any interest or inclination towards donating, the link will be in the comments of this video. Again, I just want to thank the humble clothespin for all of the things that it does and all that it shows us. How to hold tight, how to be there, how to really weather the storm. So I think that's all I've got for you today. Let's see if we can list the 6 simple machines before I go. We've got inclined planes, wedge, screw, pulley, lever, and wheel and axle. Oh, yeah! All right, great. Okay, I think now I've earned my science glasses back on, and we'll see you next time here on the Ballard Institute Facebook page with me, Felicia Cooper, on May 6th. May 6th at 2 p.m. Okay, great. Thank you so much, everybody.